Okay, so here's the idea. So we have a x is our normal random variable. Our mean is 80, and our standard deviation or variance is 16. Well, that would just mean standard deviation in this case is 4. So what we can do is in A, it's really just using the normal, because you don't get a table. Generally, you would be given a table, but that's only be done at at university at this point. So what I'm going to show you is a way of doing this. First of all, just you can do this. We don't need to actually use the z-score, and just remember the z-score is equal to x minus sigma, or mu, sorry, mu over sigma. That is, we would have to turn this x into our z by subtracting the mean and dividing it by the standard deviation. I'll show you how to do an example like that. But we actually don't have to do this. What you do need to do is enter a really large or very small number in this case, because it's always going to be done by, it calculates basically by doing everything by the left of the value. You'd actually have to do this using the table. And that's how it basically calculates. Everything is ever calculated to the left of that, of a particular value. So 78, if I'm thinking about this, it would actually look, I'd draw that and I'd say, oh, I don't know where 78 is. But if I switch to Z, it will tell me, because it always will indicate Z will be 0 at the mean. That's a guarantee, right? That's what it means. And so -1, that would be my first, that's standard deviation, and that would be 1. Z will tell you where, on which side of the mean you're on. Here, you have no freaking idea. Or actually you do, actually, because actually, wait a minute, because this is the mean, it'll tell you. So I know I'm on this side. So I'm pretty close to the mean. So ignore that. So I know right there, I know I'm somewhere there, right? So I can actually just put that in. So, but what I would need is a very small number. So -1e to 99, comma 78, and then I would just put in my 80. I think it's it would be your mean, and then your standard deviation of 4. And what you'll get is this guy. This is our probability. 3085. So that's a 30.85% chance of it happening. So here is B. Now we're going to do something like this. So, and then I'll show you a trick around it. So what you will see here is, again, what we can do is the normal CDF. And again, what we're going to do is just put in our values, 76, 84. So you know this is to the left, this is to the right of the mean. This then is going to be 80, and this will be 4. So that will give you 0.6829. So that's your probability. So we're done there. But what happens if I had to do this using my z-score? Well, I would look like this. So I would take 76 minus the mean, which is 80, divide by 4, which is, I'm going to do to everything in the middle. So this actually is going to be x minus mu divided by sigma. You know this is your z, less than or equal to 8, 4 minus 8d divided by 4. And there we go. So what we can have here is then going to be probability of the first one is I need to look at z. I'll call this my z1, which is equal to -1 actually. And here, this would be z2, I call it, and that's going to be +1. So this will just be z1 less than z, plus what we would have here or sorry, minus, I would want to subtract the probability of this one. So this would be Z2 less than, well, actually it'd be just Z less than Z2, right? So, because you would get here your 0.8413 minus your 0.1587, and you get the exact same value. So that would equal 0.6829 basically. Right? So that's the idea of how you can actually use this, and we'll do it one more time with this one to give you a better idea, because this is still, it's sometimes you actually do need to convert these, but not always actually. So the idea here is x in this case is greater than 86. You could just convert this into z, but we've seen it already that you don't have to. As long as you're given the 80 and the mean and your variance, you're going to be fine. So what we have here, though, is the probability of x greater than or equal to 86. This is the following idea. You have distribution like this, and you know the mean is right here at 80. You know 86 is here, something like that. And then you're going to say, I want everything greater than that. So what you can do, if I want all this shaded area under the curve, what you can do is it's going to be 1 minus, well, whatever is less than that. So it's a complement, right? So it's the complement. So the idea here is p x less than 86. This will then be 1 minus 0.9332. That then is approximately 0.0668. So it's a 6.68% chance. So this complement works like this. It's, if you recall from probability of event A happening plus the probability of its complement happening, so I call that prime, is equal to 1. So it's 1 under the curve. So this would be our complement of original event. Right? That's the idea. So the last topic I'll do in the next video.